This is question 56 of chapter 9 in our physics textbook. And so the question comes up is, we have a guy named Dan who's traveling on his skateboard at 4.0 meters per second. And for whatever reason, Dan decides to jump off his skateboard, propelling the skateboard forward at a new velocity of 8.0 meters per second. And it wants to know basically what Dan's speed is now as he hits the ground. So a couple other values it gave us too was the mass of the skateboard and the mass of Dan, which is indicated here. For simplicity, what I did is, we know the initial velocity of both Dan and the skateboard is 4.0 meters per second, so I have that indicated by VI. And then for the skateboard, I have its velocity and its mass indicated by sub B. So velocity sub B of the skateboard is 8.0 meters per second. The mass of the skateboard with sub B equals 5.0 kilograms. And the mass of Dan, which with Dan I'll indicate his mass and the velocity by sub D. So the mass of D equals 50 kilograms, which is Dan's weight. So once we get to this point, the way we'd solve this equation is, we know that through the conservation of momentum, the initial momentum has to be equal to the final momentum. So we know that the initial momentum is the velocity of Dan and the skateboard, which is equal because they're both traveling at the same speed, times by the mass of Dan plus the mass of the skateboard. And our final momentum is the mass of the board times the velocity of the board plus the mass of Dan times the velocity of Dan. So adding these two together, we know that the initial momentum is equal to the final momentum. So we get this equation here. From this equation, if we're solving for the speed that Dan is traveling now that he's off his board, we can just set it all equal to the velocity of Dan. And from that we get velocity of Dan equals the initial velocity times by the mass of Dan plus the mass of the board minus the mass of the board times by the velocity of the board all over the mass of Dan. And so once we're to this point, all we need to do is enter in the values that we've been given or that we found, and we should be able to get our speed of Dan when he's off the board. So we'll enter that in here really quick. We get VD equals 4.0 meters per second. The mass of Dan is 50 kilograms plus the mass of the board is 5.0 kilograms minus 5.0 kilograms times by the velocity, which is 8.0 meters per second, all over Dan's mass, which is at 50 kilograms. And once we run it through a calculator, we get the velocity of Dan equals 3.6 meters per second. And that's how you do question 56 in chapter 9 of our physics textbook.